week 3 and week 4, both weeks programming questions will cover combinedly today. And ma'am will join later. She has a meeting. So me and Sanskar, we both are the TAs for this course, and we both will cover the questions of week 3 and week 4. There are total 4 questions. So we'll be able to cover it up in next 1 hour. Let me share my screen. I'm audible, right? Can someone confirm?
Yes, you are, sir.
Yeah. So we'll start with week 3. The first question. The question is based on a game. So there are 2 players, Ankita and Biswas. And they are playing a 2-player game in which has n cards. And each of the card has an integer written on it, which is given in the list A. And Biswas has M cards, and there also each of the card has integer which is given in the array B. Now the game goes this way. So both of the player will take turn by turn, and they will put a card. And let's say Ankita has put number 4, and Biswas will put some other card. And the condition is the card the Biswas should put should be strictly greater than the card that Ankita has already put. So if you consider the game stack, like one player puts a card A1, another player puts a card which has number A2, then A2 has to be strictly greater than A1. And if the another player cannot make any move, then the other player wins, basically. So let's understand it with an example. So let's say Ankita has 4 cards, 10, 5, 13, and 8. And Biswas has 3 cards, 6, 15, and 6. And it is given that Ankita takes the first turn. So Ankita can choose any of these 4 cards, and let's say she chooses 5. Then Biswas has to choose a card which is greater than 5. And he chooses 6. Now Ankita has to choose a card which is strictly greater than 6. She doesn't have 5 because she already chose. So she has 3 options, 10, 13, and 8. And she chooses 10. Now Biswas has to choose a card which is strictly greater than 10. So he has only one choice, which is 15. And he uses the card number 15. And now Ankita doesn't have any card which is greater than 15. She has only 2 cards, 13 and 8, which both of them are less than 15. So Ankita cannot make any move, and thus Biswas wins. Right? So this is the game. And the question is, basically you are given some test cases in which you are given n, which is the number of cards that Ankita has, and the array A, the numbers represented on those cards. Then M, the number of cards which Biswas has, and the array B, the number represented on those cards. And you need to output 2 things, like first, if Ankita takes the first turn, who will win? And second, if Biswas takes the first turn, who will win? Considering both of them are playing with the optimum strategy, right? So is the question clear? Is there any doubt in the question? Okay, so does someone want to give any approach if they have submitted the answer? And
sure, sir. Can I try?
yeah, go ahead, Kusantri.
Yes. Okay. So in the question, first of all, we can see if the first player gives a card, then the other player has to give a card that is strictly greater, right?
Yes.
So if one player has a card that has the higher values than any of the other cards of the other person. So let's say if Ankita has a card number 15 and Biswas has his highest card that is less than 15. So once Ankita moves that, Biswas can't play any move, right?
Yes, exactly.
And if Biswas plays any card, then Ankita still has that card 15, so she can always win that cases, right? So this will be a one-sided win for Ankita in this case. And similarly, if Biswas has the card that is the highest, then Biswas will win for definitely, right?
Yes.
So we can directly write a if condition there and return the value of Biswas or Ankita for who will win. But the third case, that is if the highest value is equal in both cases, then we can check whose turn is first, right? If Ankita is first and Ankita is playing the turn, then she can win. But if Biswas is playing the turn, then Biswas will win. So we can set the condition according to that for the third case.
Yes, yes, yeah, exactly, it's correct. That's exactly what we expected to give the algorithm. So what Kusagra said is basically we are given two arrays. One is the number of numbers on the cards of Ankita, and one is the number of cards, number on the cards of Biswas. Let's consider the maximum of both of these decks. Let's say Ankita has a card which is number 100, and all the cards of Biswas are numbered less than 100. Right. And now let's say Ankita takes the first turn. So the optimal strategy of Ankita will be put the maximum number card, right? So if Ankita puts this 100 number card, then Biswas has no choice because he doesn't have any card which is number greater than 100. So this is win situation for Ankita, right? Because she has the maximum number card. And even it's the first turn is taken by Biswas. Let's say Biswas puts any card, but since all of those cards are numbered less than 100, in the second turn, Ankita can always put the card number 100, right? And in the third turn, Biswas will have no choice. And this is also a win situation for Ankita. So if you observe, like this basically means if whichever player who has the maximum number card, he has to put that card first in his turn, and that is the optimum strategy. And whichever has the maximum number card, he or she has the winning strategy, right? So if Ankita has a card which is strictly greater than all cards of Biswas, it is clear win for Ankita. And if Biswas has a card which is strictly greater than all cards of Ankita, then it's a clear win for Biswas. So everything clear till now? Any doubts still here? Okay, so the base case that Kusagra said, the critical case is when both of them has this, like say the maximum number card is 100 and both Ankita and Biswas both have the maximum number, like both have the card number 100. So who will win? Let's say like the 100 is the maximum number card and both Biswas and Ankita has that card. Now let's say Ankita takes the first turn. Then since Ankita also has a maximum number card, she will put 100. And the condition is Biswas has to put the card which is strictly greater than 100. And he doesn't have any card which is greater than 100. He has card of 100 number card, but he doesn't have any card which is greater than 100. So it is win situation for Ankita. And let's consider conversely. If Biswas has the first turn, Biswas takes the first turn, then he will also put the 100 number card. And now Ankita doesn't have any choice. She can't put any card above 100, right? So when the maximum number card is with both Ankita and Biswas, the winner is decided by who is taking the first turn. So if Ankita is taking the first turn, she will win. And if Biswas is taking the first turn, he will put the maximum number card and he will win. Right? So these are the two cases. When there is only one maximum number card, which is with Ankita or Biswas, not with both, then whoever has the maximum number card will win. When the maximum number card is with both of them, then whoever takes the first turn will win. So is it clear? This comprises all the cases. Right? Okay, and I'll just go through the code which I have done in Python. So here what I have done is ignore this top part. It is just for taking input and output. So I've taken the test case, the n, the array the number on cards for Ankita and number of cards for Biswas. Right now I find the max element. So max is what is the maximum number card in Ankita's deck and what is the maximum number card in Biswas decks. I will take the maximum out of both. And if this maximum, first I need to print who wins if Ankita takes the first turn. So if this maximum is in the Ankita's deck, then obviously Ankita will win. Because she is taking the first turn and she also has the maximum number card. And if it is not the case, then Biswas will win. So if M is in A, this maximum number card is in Ankita's deck, then I'll print Ankita, otherwise I'll print Biswas. And the next thing, when Biswas takes the first turn, is just converts. If the maximum number card is in Biswas deck, then I'll print Biswas, otherwise I'll print Ankita. So this is a simple code which you can do in Python as well. C++ is also similar. You can. So any doubt in this question? If not, then I'll move to the next question of week 3. Okay, and let's go on to the next question. So the second question is, there is a taxi service which is running in a city, and there are total 10 to the power 9 stops, which are numbered from 1 to 10 to the power 9, which are basically the pickup and drop for the taxi, right? And you are given a list of stops S1 to Sn, which basically denotes the taxi is going, starting from the stop S1, then it is going to S2, and at last it is going to Sn. And only on this n stops, anyone can go, like anyone can take the taxi or drop the taxi, and this is in sequence. So first the taxi will go to S1, then it will go to S2, then it will go to S3, and then at the end it will go to Sn. Now you are given Q queries which are of the form Si, Sj. What this query denotes is there is a passenger who wants to go from the stop Si to Sj using this taxi. And you need to determine if this passenger can use this taxi to go from stop Si to Sj. And since there are Q queries, the expected output is the total number of passengers who can use this taxi to satisfy their query. So for example, if the schedule of taxi is like this, first it starts from stop 2, then it goes to stop 4, then 1 and 2. And observe that there are no constraints on repetition. So the taxi can go to the similar repeated stop multiple times. So it can visit 2 twice also. So as in this input, then it will go to 6, 3, 4, and 5. There are 2 queries. First query is 2, 3. So there is a passenger who wants to go from stop 2 to 3. So that passenger has to take the taxi on stop 2. So he can take it here or here, and he has to drop the taxi at 3. So he can use either of these stops, either this or this. He can take the taxi and he can come out at this stop, right? So this query is clearly satisfiable. And there is another passenger who wants to go from stop 3 to stop 1. So stop 1 is here and stop 3 is here. If you observe, he need to take the taxi at stop 3. So there is only one option. He will take the taxi at stop 3. But now there is no stop 1 after the stop 3. Stop 1 was way before stop 3. So he cannot use this taxi to go from stop 3 to stop 1, right? Because taxi will stop at stop 5. So this query is not satisfiable, but this query is satisfiable. So the answer is 1 because only this query is satisfiable. And yeah, there is, as some of you pointed out, there is one mistake in the constraint. This constraint was not expected here. Si can be equal to Sj, but there is a type, so we will consider it during the grading. So right now, ignore this constraint. Si can be equal to Sg. Right? There are some test cases in the assignment which will validate later, like in which Si is equals to Sg, but here we mentioned Si is not equal to Sg. And Manas, you want to say anything? You have doubt? Okay, maybe you are mistakenly unmuted. So, okay, anyone want to give any approach who has tried to solve this problem? Anyone wants to share their approach? Yeah, Kusagra. If someone other than Kusagra, it is. If not, then Kusagra can go ahead. He already has given a nice solution for the first problem. No one else? Then yeah, Kusagra, you can go ahead.
Okay, so the solution I did was like for every passenger we can check that if that passenger can take the taxi or not, right? And if he can, we can just increase the count the basic way. And for checking if the passenger can take the taxi or not, we'll first go through the array and check if we find the first value in the array or not. Wherever we find, from there, we'll find the next value. If we find that as well in the array, in the remaining part, we can consider that the person can go with the taxi, right?
Yes.
And if that's not the case, we can return that the person cannot take the taxi, and therefore that will be a false case.
Yeah, correct. So you implemented just the way you said?
Sir, I don't remember exactly how I did it, because I might have tried to optimize it a bit, but I think that's what I thought at the first glance.
Yeah, that's fine. The approach that Kusagra's described is basically there are only two conditions. So there has these two stops, Si and Sj. First, both of them should exist in the arrays, right? The taxi, uh, the taxi has to stop at both of the stops, right? Then only the passenger can use this taxi. So the first thing you need to check is these three and one, both of them are in this list. So if that is the case, then you need to check if there is a one which at least one which appears after a three. Then only the passenger can take the taxi at three and leave at one. Right? And if you do it the way I mentioned, like for every query, you go through the array. So for each queue in query, you basically go through this array and let's say q equals to si comma sj. You find the first occurrence of si and check if there exists sj in this later occurrence. So how much time it will take? So there are how many queries? There are 10 to the power 5 queries. And for each query, we are traversing the whole array, which has the size n is running from 1 to 10 to the power 5. So which is also 10 to the power 5. So if you combine, like this is a nested for loop, the overall time complexity will be around 10 to the power 10. Can we optimize it further? This is the first solution that we can think, and it's a valid solution, but can we optimize it further?
Yes, I just remembered the way I did it for
Yeah,
optimization. Can I speak?
yeah, go ahead.
Okay, so what I did was for every stop, I made a dictionary, basically a map, where I stored what's the first index where I got this, like the earliest time when this taxi arrives, right?
Yes.
And for every stop I stored it, and then for every query I checked that if the first, I mean the minimum value of the first is strictly less than or sorry, not strictly, but less than or equal to the smallest index of the next, right? And if that's the case, then I can consider that the taxi will arrive first at the previous value, like the station from where the passenger is planning to go, and then sometime later it will try to achieve where the passenger is going. And not minimum, sorry, I stored the minimum and maximum both,
Yes.
like minimum for the previous and maximum for the post,
Yes.
so I can check if the person is able to go from the minimum distance to the farthest, right?
Yes.
That's what I do.
Right. Right. So that will reduce the complexity from 10 to the power 10 to just 10 to the power 5, right? Because each query you will be able to solve in order one time using that approach. So let's go through what Kusagra mentioned. So all the queries are in this format, SI comma SJ, which means the passenger wants to go from SI to SJ. And now let's see when can this query be satisfied. So this so there should exist one SI in the sequence. There should exist one SJ in the sequence, and there's the sequence in the sequence. Their order should be like the SI should be before SJ, right? Then only the passenger can take the taxi at SI and leave at SJ. So there should exist one SI which is before one of the SJ, right? If this is the situation, then only the person can take the taxi at SI and uh, the query is satisfiable. Right? So what is the condition when this like the passenger is not will not be able to use the taxi? What will be that condition? So that will be only that case will only arrive when all the SJs are before the SI, right? So if this is the case, then only the passenger cannot use the taxi because he wants to go from SI to SJ. If all the SJs are before SI, then there is no way he can reach to SJ by taking taxi at the SI stop. Right? So this is only the case that you need to capture while checking the queries. So what can you do to check this condition? So you can store two things, as Kusagra said. First is the first occurrence of SI, the first occurrence of SI, and the last occurrence of SJ. And you just need to compare these two things. If the first occurrence of S and last occurrence of SJ, if the last occurrence of SJ is less than, strictly less than the first occurrence of SI, then only the passenger will not be able to use the taxi. In all other cases, there will be SJ in one of these sequence. Like there is somewhere, if this is not the case, then there will exist one SJ somewhere here, and the passenger will be able to take the taxi at SI and will leave on that SJ. Right. The only thing you need to capture is the first index of the stop, the first index of the initial stop, and the last index of the destination stop. Right. So what data is needed actually is you need to store the first and last occurrence of each stop. If you store the first and last occurrence of each stop, then every query you just need to do a subtraction as the last occurrence of SJ minus first occurrence of SI. If it is positive, then the passenger will be able to use the taxi, right? So if you make you need to just store the first and last occurrence of each of the stop. That is the only thing you need to do optimize, right? And how we can do it in the code, I will show it in the code. So I use the dictionaries. So this is N and Q. Then this is the scheduling. This is the list S. Then I have made a dictionary. What I have done is whenever, let's say we are at the stop SI, we will check if that stop, the keys of this dictionary are the stop numbers. The S1, S2, S3 are the keys of this dictionary. So if this stop is occurring for the first time in the sequence, that means stop, this condition is false, like we're going to ask, but that means the stop SI is not in the dictionary. Then we will add this order pad I comma I. So the first index denotes the first occurrence of stop, and the second index denotes the last occurrence. If we have visited this stop only one time, the first and last both stops will be I comma I. And now suppose we are visiting the stop repeatedly. We visited it some time. Then we'll be in this if condition. This stop will already exist in dictionary and we'll just update its second index to this index. So the second part of the for loop is repeated by it. So after this for loop, we will have a dictionary with the keys as stops and the values as a two-sized array where first element is the first occurrence of that stop and the second element is the last occurrence of that stop. Now for each query, the first thing I need to check is if the first stop, so I and J are the two stops that is required. So the I should be in that I should be in the S or D, both are same. I should be in the one of the stops. J has to be in one of the stops. And so if I is not in the stop or J is not in the list of stops or all the SJs are appearing before SIs. That means the uh, first occurrence of the starting state is after the last occurrence of the destination stop. Then only the query is not satisfiable and I just return pass. This won't update anything. Otherwise, I'll update the answer as +1. The query is satisfied. Right? So is the code clear? Any doubt in the?
So what's the space complexity of this code?
Space complexity is this dictionary will use n stops at max, and I think it will be how many? Let me check the size of queue. What is the size of? So we have two arrays. One is S, and the size of S can be at max 10 to the power 5. One is dictionary, and the number of keys in the dictionary can be at max 10 to the power 5. So the space will be also in the order n, 10 to the power 5. We are not using more than n length array, right?
So I implemented a similar approach, but without declaring a dictionary.
Okay.
What I did was I initialized a variable answer for ANS, and then I checked for two conditions. First was if the first stop was in the given list,
Yes.
and the returning stop, the destination, was also in the list after the stop. If the destination is also in the list, but after the index of the start.
Okay. Yeah. Similar, these three conditions, right? The first stop has to be in the list, second stop has to be in the list, and the first occurrence of the starting stop, like the destination stop, has to occur after the initial stop.
Yeah, but I didn't have to mention the middle query.
Okay,
Middle condition.
Okay, you are just checking if there is a J after I. You are not. Yeah. That
Yeah.
will also fine. But you don't have any dictionary. So for each query, you are doing it repeatedly. You are finding the index of J just after I repeatedly, right?
I'm just checking if J is in the S and then braces, and means I'm slicing the list and then I'm checking.
Okay, but that will also, if the number is SI is the first element and S is the last element, then it might take order and time to check that, right?
Yeah.
Yeah. But that is also a valid solution. Yeah, it will give correct answer. Yeah, both of these and the first approach, then the optimized approach, and that you mentioned, all of them will give correct answer. But the difference will be in time complexity. This dictionary will give constant time on queries. That's only benefit. Yeah, any other doubt? No, then we can move on to the week 4 part. Great. Yeah. Sanskar, are you here?
Yeah, are you able to hear me?
Yeah.
Okay, I'll share my screen now. Just confirm if you are able to see the screen.
Yes, Sanskar.
Okay, so I think I should maybe use the OneNote to explain. Maybe that would be easier. Okay, so here I'll be explaining the solutions to both the programming problems from week 4 and sorry. Okay, I think someone is unmuted by mistake. Okay. So in the first problem, we were given that we had two queries, query 1 and query 2. Can you please again confirm if you are able to see the current OneNote page that I'm drawing on?
Yes, so the page is visible.
Great. So we had queries of two types, and in the first query, we were asked to append a list. So we are about to have a list of blocks, and these blocks would be of different colors. And a query of type 1 would be appending a block of a particular color, let's say X, to the end of the list. So initially the list is empty, so we push X into the list. And again, if we have a query of type 1 again, but if we have a color, let's say Y, our list would look something like this. But again, if we have a query of type 2, which asks us, so it has two parameters, color 1 and color 2. It asks us to convert the color of all the blocks that are colored initially with color 1 to color 2. So let's say if this query, in this example, we call query of type 2, and we want to convert all the color Y blocks to color W blocks. So what we'll do is we'll search through this space. We find that we only have a single block of color Y, and we'll convert it to color W. And in the end, we want to output the whole list. Now, the technique that I used was merging sets using small to large merging. If someone would like to share their approach, they are free to do so. So would anybody like to share their approach? Okay. So yeah, this problem was on the more difficult side. So it's understandable if you were having some kind of trouble while trying to solve this problem. Okay, so now I'll explain what was my approach. Okay, so what I used was, the technique I used was small to large merging. I'll try to explain how and like why I use this approach. So the time complexity of this approach is n log n if we have n blocks in the end. And I'll just explain. Okay. Oh, sorry, Kushagra. Yeah, sure. You can explain your approach. I didn't read the message before. Hello.
Am I audible, sir?
Yeah.
Okay, so sir, what I did was, first of all, I created a basic DSU structure using a class, and then basically I did some modifications to it. And while I was merging, I was also taking the count of like what is the color of that set. Okay, so let's
Okay.
say we have a set, and we basically, if we don't have that color in the set already, then we'll add that value, and we'll add that to a color set. Okay, so every element will basically the leaders of every set will basically map to the color they have. Okay, and when we have to change the color in the query of type 2, then we basically just merge the sets with making sure that the leader is updated to the color that we are trying to place. And I used a DSU structure for that basically.
Yeah, that sounds about right to me. So what you did again was with queries of type 1, you just added that particular element to the DSU set of that particular color.
Yes.
And with every query of type 2, you considered both the colors and used DSU unite operations to make one color to the
Yeah.
switch the colors, right?
Yes. And if the color doesn't existed already, then I can just add the value as a new color. And if basically the color that we're trying to change doesn't exist, then we don't care at all, right?
Yeah, makes sense to me.
Yeah.
Yeah, so this is also what I did. So in this, okay, so I'll just again reiterate what Kushagra was trying to say and what I did. I'll do this by going over the example that I have over here. So I'm considering this sample case. So initially, we have a query of type 1, which says add 3, a color block of color 3. So I add 3. Then it says add 1. I again add 1. Now it asks me to convert all the blocks of color 1 to color 2. So this block is no longer of color 1, it's of color 2. Again, I add a block of color 2 to this query and a block of 1 and then again 2. So I'll have something like this. And then it wants me to convert all the 1 colored block to 3. So this would be 3 now. And yeah, you can see this is the answer. And what I do is whenever I have a query of type 1, I maintain. Okay, so I'll just go over the code as well. I think that would be a bit easier to explain for me. Yeah, so okay, so for queries of type 1, I just insert the index at which, or the position at which we are inserting that particular element. I insert into a list of all the elements. Okay, so I have a list, or let's say vector, of positions of all elements of a particular color. So let's say if I have a color X and I want to insert it over here with query of type 1, what I'll do is I'll insert it into location at index X. So this thing, it has all the locations of all the blocks that are colored X. So I just insert it over here and I update n. Initially n was 0. And if I have a query of type 2, after X, I'll again take the input Y and I want to convert X to Y. If X and Y are same, we'll just move on because that's the same color. We don't need to update it again. But if they are not the same, I'll get, so these locations X and locations Y, these contain all the position at which we have a block of this particular color or this particular color. I check if the size, let's say the size of this vector for X is greater than the size of this vector for Y, then I'll just swap it. I just did this thing for a shorter code. What I want to do is I always want to add the, if let's say I have a set X and a set Y and it has size 1 and this has size 2, I would always want to add the smaller set to the larger set. And this is exactly what you guys learned in the DSU lectures. While uniting, you always add from small to large. And that is why you get the log n complexity. And again, I'll reiterate why you get log n complexity. This is because every time you, okay, so let's say we have n elements in total. And some of these elements, like all of these elements are contained in certain sets. Whenever I merge a set, I merge from small to large. And let's say the size of small is X and size of large is, let's say, X plus 5. So after I merge this, the size of small would be again 0 and size of large would be 2X plus 5. We can see that the size of X is increased to 2X plus 5 now. So every time I merge, I increase the size of the smaller set at least 2 times. And okay, so I do this at least, increase the size at least 2 times. And as we have n elements in total, most number of times we can merge this set, because every time the size is increasing by 2 is log n, because we can have a number and multiply it by itself. Sorry, we double it every time, log n times, then only we'll have. So this is log n base 2, and that's why I have n log n complexity, because I can perform this operation at most log n times, and I have n elements. That is why I have this complexity. So yeah, I merged small set to larger set, and yeah, that's all. That was the main crux of this problem, merging from small set to large set. Okay, so if you guys have any doubt, you can doubt with what I said, or maybe if you want to share another approach, something else that you thought of different to this.
Sir, one small doubt.
Mhm.
Sir, if we do with rank DSU by rank and path compression, won't the amortized complexity will be O of n?
Okay, so you're saying, so the way you did using the DSU structure, I think the complexity would be order n only. The way I did, it was a bit different, because I was I didn't really have some sort of DSU tree. I was doing this with vectors. So yeah, this code would be n log n, and the approach you said, yeah, I think that would be order n.
Okay, thanks, sir.
Okay, it seems that everybody has got this question. Okay, so I'll move on to the next question now. Yeah, so the next question was really interesting question. So what we had, we were given a permutation. Okay, yeah, sure. So we were given a permutation. In the sample case, we had 4. Okay, sorry, 4, 6, 2, 1, 5, and 3. Now, so the wording of the question was kind of like, it was a bit complex, but I'll try to explain it in a simple way. So what we were supposed to do, let's say we are at 4 currently. We are at the first index currently, and it says 4. We'll move on to the 4th number in this array. So this is the first number, this is the second number, this is the third number, this is the 4th number. So we'll move on to the 4th number now. We'll go over here and we connect these. What we were trying to find, we were trying to find cycles and the size of the cycles, and I'm trying to explain how we find these cycles. So we were at first index and we had 4 written over here. We moved on to the 4th number in the list. Okay, so we are at 1 now. Now it says 1. So what I'm doing is, whenever I am at a particular index, I try to move to the number that's written at that index. So when I'm at 4th index, or if you are using zero-based indexing, that's the third index. But while explaining this, I'll use 1-based indexing only. In the solution, I'll explain how I did it with zero-based indexing. So I had 4 over here. I moved to the 4th number, and I have 1 over here. So I'll move to the first number. So the first number again, it's this one, and we can see that we found a cycle. If we have found a cycle, that's great. So let's see the elements for which we don't have the cycle right now. Let's start from the second number. We have 6 written at that index. So we'll move on to the 6th element in this list. And we have 3 written over here. So we'll move at the 3rd element in this list. Now we have 2 written over here, and now we'll move to the 2nd element in this list. We can again see that we have a cycle. So the cycle is the green thing that I've mapped over here. So this green thing is the cycle. After we found the cycle, we'll move on again we'll try to find the next cycle. The only element that isn't in any cycle is 5. We'll move to the 5th index now, but we can see that 5 is itself at the 5th index. So it's a cycle, but of size 1. So that's what we were trying to do in this question. And we had to tell for every element the size of the cycle that it's a part of. So for this one, we can see the red cycle, it's of size 2. It only contains this thing and this thing. So we'll have 2. For 6, we can see the size of the cycle that it's a part of is 3. It contains 6, 2, and 3. This is also part of the same cycle, and this is also the part of same cycle. As for 5, it's a part of a cycle of size 1. So the answer for this particular index is 1. And again, for 1, it's a part of a cycle of size 2. It only contains 4 and 1. So 2. So this is what we were supposed to do, and the output for this particular case is this. So 2, 3, 3, 2, 1, 3, 2, 3, 3, 2, 1, 3. If you guys have any doubt understanding this question, you can ask. I'll try to explain it in a more clearer way, and then we can maybe move on to the approach or the code. Okay, seems like you guys have understood this problem. If anybody would like to share their approach, they are free to do so. Yeah, sure, Kushagra, you can share your approach.
Okay, sir. So here I did with two approaches. I mean, first of all, first approach that I did was DSU. So for every node, sorry, for every index, I just merged it with the element that it maps to. So for let's say for first index, we'll go to from 4 to 1. So we'll
Yeah.
map it with the value that we have at that index, right? So I'll map 1 with 4, then for the next I'll map 6 with 2, then 2 with 3, and so on. And then when I keep mapping and merging these sets, at the end what I'll get is a collection of sets that are of the size that they belong to, right? So 6, 2 and 3 will go into one set when they merge. 4 and 1 will go into one set, and 5 will stay in one set. And that way I can just check the size of them at the end and print that directly. That was
Yeah, that makes sense. Yeah.
that was the first implementation, but it was obviously very long to implement, so I tried another implementation. Second one was basically using sets in Python. So I created two sets, a global and a local set. So a global set was made outside the loop, the initial loop that was used for traversing, and inside I just made completely ran through the cycle. Like from 4 I went to 1, and then from 1 I went to 4, like that, and from 6 I went to 3, from 3 to I went to 2, 2 to 6, and whenever I went to a value that is in that cycle, that is in the local set, then I'll just say basically set the values of all those indexes to the size of the set that I got, and I'll add all those values to the global set so that I don't visit visit the same cycle again later on.
Yeah, that also makes sense. Yeah.
Yes, sir.
So both of these approaches seem to be correct, and the one that I used was the one that you were trying to, the first approach that you were talking about. And yeah, so for me it was a little. So the approach that, like the first approach that we were talking about, that Kushagra said, I used that approach, and I had did this problem, like a problem similar to this problem before, so it was a bit easy for me to implement this. But again, the implementation could be a bit difficult. So in comparative programming, it's generally observed whenever you are given the word permutation in a question, uh, you can think about cycles. So in this problem also, we told you to find cycles. We explicitly told you, but in CP generally, whenever you are given permutation, there are some hidden cycles. So in the problem you won't really be given the word cycles, but always try to find like relation with cycle in permutation, and I think that would help you in some of the problems that involve permutations. Okay. So yeah, what Kushagra said, I had a DSU structure, and so here I'm initializing this structure, and I'm traversing over this this array 462153. Let's say I have this next variable, and this next is it represents the the thing that is next to the pointer that I'm currently at. So let's say if we traverse this one only, we are at 4 currently. And so the next thing would be the fourth element. We are at the first element, and it says 4. So next would be 4. And what I'm doing over here is I'm traversing over the whole cycle until I reach the element that I started from. So here I'll move from 4 to 1, and from 1 I'll move to 4 again, and I find that I have came back to the element that I started from. So I'll stop over there, and then I'll continue traversing this array. Uh, yeah, and while I was traversing the cycle, I also unite these indices because they belong to the same set, and I update next because while I travel, like, to compare the starting index with the element that I'm particularly at, I need this variable next to be updated every time. And yeah, that was it. I just traverse over this cycle from 4 to 1, 1 to 4 again. I find that I'm again at the index that I started with. I stop. I go to 6. From 6 I go to 3. From 3 I go to 2. 2 to 6 again. I stop because I am at this index that I started with. When I reach 2, yeah, so now when I'm reached to this implementation, it's not really the most efficient implementation because i'm I'm going over the cycle again, and that's not what we want. So here we can actually check before. So here we can check if they have the same parent, or if you can, maybe your unite operation has this check already in place if these two elements have the same parent. So when I'm at 2, I'm checking 6, and I'll check if they have the same parent in the DSU. There's no need of combining or uniting and moving forward with the cycle. I can just put a break statement over here if they have the same element, and we'll not run over the cycle again. So yeah, that could be an optimization that we could have think of over here. And yeah, that was the problem. You traverse over these cycles, and you you find the size of these cycles and break whenever required. So if anybody has a doubt with this particular approach, they can ask again. And if someone would like to share another approach, a different thing that thought of which didn't really work, or if it worked, and if they want to share, yeah, you can share. Yeah, looks to me that everybody got the approach for both these problems. So cool. Because DSU, so for competitive programming, DSU is a really interesting topic, and you can find a lot of these problems. If you want to practice more of the problems for this from this topic, go to codeforces.com, and in the problem set, they have an option of tags, and you can put the tag of DSU. You'll find really interesting problems, and yeah, this is a really fun data structure. You can try to play around with it more. And also keep this in mind, the permutation thing. You can find cycles in permutation, and these help in various problems. Cool. So I think we are done with week 4 problems also. I'll ask Gaurav Bhaiya to take over now. Thank you.
So we can close the session if there are no doubts in week 3 and week 4. If there are any, please feel free to go ahead, or we'll just close the session for today. Yeah. If there are no doubts, feel free to leave.
Sir,
Yeah, Kusagar.
sir, I have doubt, but not from the course right now. I did a problem on lead code, and in that, I did the problem with two complexities, right? From one from order of n square and the other from order of n. So I actually found that order of n square was performing better in that solution compared to order of n. And I'm very confused, like why is this happening? Can I
So,
share my screen and show it like
yes,
the
yeah.
sir, is my screen visible?
Yes.
So sir, here uh, this was the first this was the linear approach I did. So you can see that basically I'm just running one loop in which I'm just multiplying the value and dividing it, and this was basically just the entire implementation. The question was basically the finding the number of unique paths from the top left corner of a matrix to the bottom right corner of the matrix, right? We were given the number of rows and columns. So in the first implementation I did basically a linear one, and the other that I did was with DP, and there I created an entire matrix, and I ran two loops, and for every cell I counted the number of paths we can have till there, and then I return the last value. Now here the interesting thing is that in the memory we can see that here I literally created an entire matrix, right? So the space complexity will be order of n square, and the solution here beats 74.81. But here it also beats 74.81, whereas I didn't created any matrix. I just created two or three variables, basically just one variable res and not anymore, and one arrays.
Mm,
Also sir, in runtime you can see this one beat 31.18 when it was linear, and when it was order of n squared it was beating 76.45.
Okay. So this percentage denotes how many solutions it is better than.
Sir, just a sec. Here sir, we can see the runtime that this is
Okay.
this is the runtime of the solution that is order of n, and this is the runtime of the solution that is order of n squared.
Okay. Okay.
Yeah, that is what is confusing me. Memories seem to be both the same for the both 13.8 MB.
Hmm.
And whereas in the order of n square solution, I also created a matrix completely like here. This is the complete matrix I created DP. And that is also taking the same amount of space as well.
Okay, I see.
Yes, sir. This is what confused me.
Yeah.
Mostly in job interviews or most of these problems, like from lead code, they come up in job interviews, and these problems don't really. So if both of your approaches are having the same memory while running on lead code, I think it should not matter much. If you have a better time complexity and space complexity, yeah, you can move on with that, because these recruiters, they don't really stress test your solution. They, if you have a particular solution of a particular time complexity and space complexity, and it is within what they were expecting, they'll move on with. They'll ask you to move on with the code, and these solutions would be acceptable. But then, if you give solution with complexity that exceeds what they were expecting, they don't really consider that as good. So I think, yeah, if you can submit like the best solution that you have on lead code, but again, these percentages, I don't think that they mean a lot. But yeah, if you want to find like on the same page only, when you where you had showed that it beats 74.81% solutions, if you click on the last the last 90, like the 90 at 99 percentile, they also had a small bar, and if you click on that bar, they'll show you the solution that beat 99%. You can check that. Maybe that will help you with why your solution was taking a bit more time or space.
For those
Okay.
numbers, and I think it might be due to the test cases also. And the test cases are such in a way that both of them are taking the same time.
So-
Yeah,
space
yeah.
complexity, I'm not sure. Like, since that you are storing only variable in the first one, that I'm not sure how it code works. But time complexity, maybe it might be due to the how the test cases they have made.
So for time complexity, I also thought that it might be because in the order of n solution, I multiplied and divided a lot of times, and in the order of n squared solution, I just like added those
Added and
values.
yeah.
So I think the multiplication might be a bit more complex than addition.
Yeah, if the numbers are larger, then multiplication will take.
Yeah, I think that could be a case for runtime. Actually, therefore, I was more confused about the space complexity.
Yes.
And yeah, because I was more interested in this because sometimes in contest, basically the very small optimization sometimes help us complete the code and it works
Yes.
at the end. Yeah, so that is what I was very interested about.
Okay, like I don't have like I also can't clearly see why the space complexity is differing this much. Maybe
Yes,
we'll
sir.
think on it. Let's say we'll catch up on Discord.
Yes, sir. Sure.
Yeah.
Thank you, sir.
Okay. Any other queries? And no. Okay, so we can close the session now.